Okay, good afternoon. My name is Wolfgang Stripf. I'm retired from Siemens since 10 years. I can get rid of iLink. I don't know how to do it. Okay, iLink safety. This is my hobby. Because the last 10 years in Siemens, I worked for ProfiSafe, so I have kind of a little experience in the safety arena, so it was quite natural that I took over the responsibility for iLink safety. Yeah, safety is a tough job, as you know. And we finished our work last year in April, so version 1.1 of our specification is ready. The test is already done, so implementation are happening now. But we are in kind of a tunnel trip because safety is a tough process and normally you need a lot more time to develop things than in normal cases. So I'm not ready to give you such nice presentation than my wireless colleagues. But anyway, let us go through, again, the requirements of customers and manufacturers. We have a transition necessary from, like in normal IO-Link, from CO mode to IO-Link communication. And in our case, a normal input signal is not sufficient. Therefore, in safety, we are talking about OSSD. And I will explain what it is. Okay, then the next question. We already have a lot of safety communication profiles. Why do we need another one? I will give an answer to that one. And then what we achieved so far. Test and assessment. Then integration is always an item, and then development support. This is the situation for today for the manufacturers. They have field buses here and safety communication profiles on top of it. There are safety PLCs, there are safety devices directly connected to the field bus. And like robots, drives, and so forth, very comfortable things. But there is still a lot of business with standard remote IOs. And this is the focus where we are looking at, in our case. So let's have a look at the field bus situation. Yeah, IO-Link safety, contra a lot of FSCPs worldwide. They are all standardized in the IEC 61784-3-X. I was working in this area and we try to establish now IO-Link safety within this working group in the IEC. We do not like to have the same name here because we are not a field bus based solution. And therefore, our solution should be placed in IEC 61131-9-something. That's the idea. Whether we will be successful or not depends on the IEC process. Okay, so now the customer situation. Machine builders, they decide on the type of field bus first, depending on what their machine customers want to see. So that's the first decision, the field bus and the FSCP. So, and therefore, they have a lot of complexity inside their company because they need devices for FSCP1, FSCP3, FSCP6, and so forth. So this is a lot of work, and some of them, I learned, have more people in the development departments for the connectivity, for the different communication profiles than for their original technology. So this is not what we are heading for. As a consequence, there is a high degree of persistence to stay with the classic interfaces. Why classic interfaces? And what is a classic interface? This classic interface is such thing like OSSD. We come back to this later on. Or 4 to 20 milliamps. Why? It's easy. That's standard. It fits to any of these field buses. It fits to any of these markets, be it Japan, be it the US, be it Europe. Yeah, these interfaces are standardized all over the world. Therefore, they all tend to stay with these interfaces because it's more convenient. However, they cannot participate in our field. We are heading for Internet of Things, Industry 4.0, and so forth. And that's why I called my presentation Digitalization. I learned in English language there's a difference between digitization and digitalization. Digitization is only make something digital, and digitalization means the whole world digitized. Okay, and then we can see here, a number of new applications in smart manufacturing. In the IEC, there are working groups looking at smart manufacturing. Smart manufacturing means you do not have fixed production lines, but you have production cells, and these production cells can be individually combined to different production situations. That means each of these production cells need their own safety. So there is a lot more requirement to add safety to these flexible manufacturing cells. Because people can run around or interact, keyword is cobots. Then we learned that there are totally new applications requiring more measurement sensors, like strain, torque, pressure, and so forth. And more measuring sensors for object types. Now we have only laser scanners if somebody is approaching to the machine. But in the future, you will have other stuff like face recognition and whatnot to differentiate. And then we learned there is not only sensors and actuators. We had this wonderful gripper presentation where we learned IO-Link is very much suited for mechatronics, so a combination of sensors and actuators. And then, last but not least, there is miniaturization. Here. This is the smallest IO-Link sensor I have seen so far. It's smaller than the cable size. Okay. Now our solution. Here you have this situation with the remote IOs. These interfaces are standardized. However, for analog input you need modules, for analog output you need modules, for digital input, digital output. So a lot of inventory. You have to present to your customers. In case of IO-Link safety, we have only one functional safety master. It runs IO-Link safety, and you can connect whatever you want. Not very good for product managers in these companies here, because it's called cannibalizing. So these things will cannibalize this business. And this may be one reason why companies are kind of reluctant to jump into the IO-Link safety bandwagon immediately. Okay, this is the hierarchy we have already seen, and there is no separation here. This is the pyramid, and in the pyramid we have the standard IO-Link devices, like masters, and here the IO-Link safety master can drive the safety devices, but in addition, standard devices. So the safety master can be used for standard, non-safety, and for safety devices. So that should allow for easy applications and cost-efficient applications. So OSSDE, what does that mean? We do not have only one signal here, like in standard IO-Link, switching and communication. We are using this free pin 2 for this second redundant input signal. And here we are working closely together with ZVEI. They have a position paper, and we are standardizing our OSSD solution to Type C class 1, which is classified in this ZVEI paper. And this, I was told, is 80% of the market. That simplifies the task of the developer because he does not have to think about complicated new strategies, how to do these testing signals and so forth. There is a lot of stuff out there in the market and it's totally unnecessary. So we are standardizing on one, and then we can improve the situation for the master input, for example. There is no filtering necessary for discrepancy and all these different things where you are fiddling around with the parameters. Okay, so is the possible migration strategy. ProfiSafe came out in 1999 as an example. So the original safety sensors could be connected to these FDI modules, or the sensor manufacturer could develop a device directly for this particular functional safety communication profile. Now we have IO-Link Safety 2018 together with the ZVEI guys. Now this guy has two possibilities. He can connect directly to the FS Master because we have a migration strategy. An FS Master can be built with OSSD support or not. This is an option. It depends on the manufacturer of the safety master, of the FS master, whether it supports OSSD or not. The safety sensor manufacturer, he can develop a new device supporting OSSD like before. So that's a market strategy. He can deliver his device for all the standard application the customer is used to, or switching mode, then it can run communication. So this has two modes like any other IO-Link device we know, except for safety. So this is a strategy. And one issue, especially for safety manufacturers, safety device manufacturers, is the switching does not allow to communicate with the device normally. So the device manufacturers were forced to add another interface. I've seen USB, I've seen RS-232 and whatnot. So in my previous life with ProfiSafe, I had these kind of cables for any of these devices to parameterize and to diagnose and whatnot. Now with IO-Link, it's much easier. You can use the standard cabling of this device, and you can parameterize for use on FDI modules. So IO-Link safety communication, what did we achieve so far? This is the main specification. Back in April 2018, we had to create a lot of papers for the safety assessment bodies like BIA and TÜV. Here are the reports. This is the BIA report, and this is the TÜV report. We have the test specification. I will come back to this one. And safety integration is now available as a white paper. The principle is following the black channel approach. So we do not need safety here on this normal IO-link level. So it is untouched. And we put a layer on top of these layers here on the communication layers. That's a principle. Okay, this is the first answer to the IO-link wireless question. Normally, for safety protocols, besides your safety data, you have some safety code. In our case, these are at minimum 4 octets, 4 bytes. For process data, up to 3 octets. If you want more, up to 25 octets, you need 32-bit CRC at least, in our case. And for the management of the protocol, we have this byte here for control and status. And we had to change our protocol. That was the reason for 1.0 to 1.1, because we found out the master manufacturers, they have a modular concept to reach their ports. And due to this modular concept, we were forced to increase the size here by a port number to address the individual port. So we have this size here, this safety code to transmit in wireless, at least this one. And this is something we have to discuss. Okay, this is how IO-link works. You have this startup cycle here running from CO or OSDE. We have the wake up. In safety, we need a little bit of modification because the safety devices, they have a startup self-testing, and this self-testing is usually more than 300 milliseconds that we require for IO-link. Therefore, this is a little bit modified. But after a so-called ready pulse, we wake up the system and we start communicating all the stuff we know from IO-link. From there, we go to a so-called pre-operate state, and this is very important for us here, because here we have a mechanism that is verifying the safety parameters in a diverse way. So the safety parameters are checked, and we have some authenticity checking. So we find out whether two safety devices are switched by chance between 2 ports. So the system is not starting. You get an event that there is a misconnection, either between 2 masters or between ports. It doesn't matter. And if we have certain conditions in this area here in authenticity, then we can start a replacement. So we only can use out-of-the-box devices for replacement. They are not allowed to have authenticity parameters. And in version 1.1.3 here in the IO-link specification, we have now a new reset command, which is called back to box. So that it's very easy to understand. Yes, I need this command, system command, to reset my device to an original delivery state. Okay. Once our our parameters are verified, then the safety communication is starting. That's the principle. Now, test and assessment. These are the major clauses or chapters. The OSSD testing, FS device functions, FS master function, SCL test. I already reported about this one. This was the project with IFAC, where we did some simulation and automated test script generation. then FS Master tool tests, assessment and certification. So we are now with version 0.9.5. This was the project with IFAC in Magdeburg. So we can use these test scripts. They are approved by TÜV. So we are all set. And our tester providers, they can use these scripts for protocol testing. This is how the FS Master tester is working. And our technology provider, TE Concept, is working very hard to realize this new FS Master tester. And this is the concept. We want to use the new SMI features of version 1.1.3. And since we are late in comparison to ProfiSafe, we could learn how they did it, and we did it a little bit more clever, because we can now establish some safety parameters to bring in this connection in the safety layer here. And this allows us to test the safety layers independently from the FSCP. So IO-Link safety is totally independent from any of these FSCPs. We can test it separately because that is a question of cost. To run it with the FSCP means for each FSCP you need an own tester. And here we can test the IO-Link safety independently. So it reduces the effort. Device tester is based on the normal tester we have for non-safety devices. And here the strategy of these tester companies, technology providers. We have Mr. Willems from TMG here. You can ask questions. And the FS Master is developed by TE Concept. Dr. Witte is not here. Oh, that's somebody from this company. So the FS Master is developed by TE Concept. They are working very hard. And here the FS device tester is also in progress. And the first stage will be the SCL test alone, because we have the scripts that are approved by TÜV already. So this is all set. And the tests, the rest of the tests will come later, once we finish the test specification. Integration is very interesting, because you have to integrate into an FSCP, and that's pretty challenging. So Mr. Maul is working on the IO-Link integration, edition 2. And we already prepared a white paper for this, for the next step. Once this is here finalized, then we want to integrate this white paper for IO-Link safety into this Profinet integration paper. We extracted from this here a neutralized paper that can be a role model for all the other FSCPs. This is here how it works. Here you have the ProfiSafe down to the so-called linking module in the integration paper, and from here we have the IO-Link safety on top. And many people tell me, oh, this is bad stuff. The master has to be safe, and this is a lot of cost. I tell you what, this is totally not true. Because we are using the original master, not safety related, except for two things. One thing was the wake up, as you remember. We have to create a ready pulse, or we have to check in the master the ready pulse once the device is ready and the master can start the wake up pulse. So that's a little change down in the data link layer. And the next one is you have seen the message, the safety message, the yellow part and the gray part. And we have to split the message that comes from an FS device, for example, into the safety part that goes up to this gateway part, and the non-safety part that goes up to the gateway here for non-safety. So we split these two parts, and the safety stuff is processed here in this mapping, gateway mapping. So this is a little part here in this whole entity that has to be safe. And naturally the tools as well, but not at that high degree. Okay. Now the technology providers, I mentioned TMG and TE Concept. The development support in the first step, TMG provides functional versions for FS device and FS masters. These are available. There is no SIL for them. They are only working like the protocol is requesting. Therefore, it's great here. Yeah. So these FS master and FS device are available, and somebody who wants to develop an FS device, for example, he can use this functional FS master for testing and so forth, whatever it's requested. And on the other hand, master developers can use these functional FS devices for their work. And in the next step, we intend to provide starter kits, and these will be functional safety versions. With safety development, with support from assessment bodies such as TÜV Süd, we will create pre-certified SCL drivers. SCL is safety communication layer, is the protocol driver software for up to CL3 and PLE, assessed on one hardware. So this is a requirement. It's only possible. You cannot assess software alone. You have to provide running hardware. So we will have 2 certified drivers, one for FS device and one for FS master. So architecture, design and testing. Architecture for CL3, for example, it's a must that you have redundant microcontrollers, for example. How you design it, it's up to you, but there has to be some redundancy. Then, of course, these drivers have to run in different microcontrollers. We had the same problem 20 years ago with ProfiSafe, and we thought ANSI-C is a good solution, but we learned ANSI-C is not ANSI-C. So you have to do some more to have a real independent code, and coding should follow MISRA standards. Okay, product and marketing strategy not yet decided. I think SPS Fair will, these companies will show their strategy. What's next? Okay, we will finalize test specification. We are expecting FS master and FS device test in third quarter of 2019. I already told you, first step is SCL test, because that is fixed. Then the white paper will be incorporated in the integration spec. Then we are trying to encourage and enable other FSCP integrations. We are talking to FSOA, SIP safety, and so forth. Important is we prepare an IO-Link safety workshop on 9th and 10th of October. We already have quite some number of participants, and you may hurry up. Then for next year, we will start with certified designer training classes in spring 2020. And then we already have a student from Hamburg with us, and he's in charge to talk with us about protocol extensions for iLink Wireless. So this is the second answer to your question. Thank you very much. These are the working group members. Thank you. See you, hopefully,